Hey everyone, welcome back. This is lesson 8.3, Adding and Subtracting Rational Expressions, part 2. All right, in this problem, we're going to talk about subtraction. So the first thing we really need to do when we're adding or subtracting our fractions is make sure we have a common denominator. So let's first look at our common denominator. And no, we do not have common denominators, but I can factor this x squared minus 9 because I recognize that it is the difference of two perfect squares. So factored, it's going to be x plus 3 and x minus 3. And now I see that the only thing I'm missing from this term is an x minus 3. And if I just go ahead and multiply an x minus 3 to this side, then now I have common denominators, x plus 3, x minus 3 on both. All right, but if I multiply in the denominator in x minus 3, I also have to multiply my numerator by the x minus 3. All right, so let's go ahead and get this whole thing written out. Let's go ahead and FOIL this piece, x plus 5 times x minus 3. So x squared, and then this is going to be minus 3x, and then plus 5x, and then minus 15. All right, and now the thing that I want you to remember is this whole piece is subtracted. All right, so we have 2x squared minus 30 minus this whole piece. So what I have to do is change the signs on every single part of this. All right, so I'm going to say I'm going to change this to plus the opposite. This is going to be a minus. This is going to be a plus. This will be a minus, and this will be a plus. Now that I have them all changed, I'm going to go ahead and gather up all my like terms. I have a 2x squared and a negative 1x squared. That just leaves me with x squared. And here I have a negative 30 and a positive 15. So I'm going to end up with negative 15. And my x's, I have a 3x and a negative 5x. So that's going to be minus 2x. All right, and all of that is going to be over my common denominator of x plus 3, x minus 3. All right, well, I'm not quite finished yet because I want to go ahead and see if I can easily factor this piece right here. All right, and so what I want to do to factor that and say, are there any two numbers that multiply together to get negative 15 and add together to get negative 2? Well, yes, there is. How about negative 5 times positive 3? Negative 5 times positive 3 is negative 15, and negative 5 plus a positive 3 is negative 2. So I know that I've done that correctly. So what I can do is just factoring out that piece, I'm going to say x minus 5 times x plus 3. And all of that is over my common denominator of x plus 3, x minus 3. And now that everything's multiplied together, I can actually cross out by dividing both sides by x plus 3. And that leaves me with x minus 5 over x minus 3 as my final answer. But I have to be careful because I haven't finished yet. It says identify any x values for which the expression is undefined. So I have to go back and look at this piece right here. All right, I have to make sure that I am checking the original common denominator. So I see x plus 3, and if that equals 0, x would be negative 3, and x minus 3 equals 0, so x would equal positive 3. So that tells me that the expression is undefined at x equals 3 and x equals negative 3 because these values of x make the factors of x plus 3 and x minus 3 equal to 0, which would make our expression undefined. All right, go ahead and turn your video off and try this on your own and see if you're understanding this okay. The one thing I will warn you, it doesn't factor out nice and beautifully at the very end. So just in the interest of time, let's not do that for today. So just get it subtracted and then you'll be good. All right, turn your video back on when you're finished. Okay, so let's get going here. The first thing I want to do is subtract, and so I need to check and make sure I have common denominators. And when I look at them, I see that they are not. But I do know if I multiply 5x minus 2 on this side, and if I multiply 2x plus 5 on this side, I now do have a common denominator. So the next thing I need to remember is if I multiply on the bottom, I have to also multiply on the top. And if I multiply on the bottom, I have to also multiply on the top. Okay, next I want to just go ahead and distribute this all through. So I have 15x squared minus 10x minus 6x plus 4. On this other side, I'm going to distribute, and I'll have 4x plus 10. All right, and there's a minus sign here, and I've got to subtract the entire thing. All right, and now that I'm going to do that, I can go ahead and write my common denominator just as one piece. Here we go, 2x plus 5. Now, the next thing I need to make sure is I need to distribute this negative to both of these two terms. So I'm actually going to have a negative 4x and a negative 10. All right, so grouping everything together, getting all my like terms together, I see I have a 15x squared. I have a negative 10x and a negative 6x and a negative 4x, which gives me a negative 20x. And then 4 plus negative 10 is negative 6. And all of that is over 5x minus 2 times 2x plus 5. And here's the part, this piece right here is a very long, you have to do your quadratic equation, and so I'm not going to make you do that for right now, but usually you will need to go ahead and do it so you can see if there's anything else you can cross out. So in this case, we need to go back and identify the x values for which the expression is undefined. So let's set everything equal to 0. 5x minus 2 equals 0. Add 2 to both sides. 5x equals 2, so divide both sides by 5. So x equals 2 over 5. When x equals 2 over 5, our equation is undefined. And also, let's do the other one. 2x plus 5 equals 0. Subtract 5 from both sides. We end up with 2x equals negative 5. Divide both sides by 2. So when I have that x equals negative 5 over 2, my equation is also undefined. All right, so there it is, when x equals negative 5 over 2 and x equals 2 over 5, because these values of x make the factors equal to 0, and we don't want that to be 0, otherwise our equation is undefined. All right, here's one for you to try on your own. I will say that at the end, after you add all your like terms together, you will be able to factor that. And so go ahead and factor it out so you can get to the final answer. Turn your video off and give it a try. All right, so on this one, it says to subtract, and I need to notice that I have fractions, so I need to have a common denominator. So I'm going to look at my denominators, and the first one I see, x squared minus 64, I see that it can be factored. It's the difference of two perfect squares. So that's going to be x plus 8 and x minus 8. Now that I have that, I see I already have an x plus 8 on this side, so if I multiply by an x minus 8, now I have a common denominator. All right, so I'm going to go ahead and multiply by my common denominator on the top. And so I can see that my first half is 2x squared plus 64. All right, and I'm going to minus, but remember I have to minus the whole thing. So let me go ahead and FOIL this out. X times x is x squared. X times negative 8 is negative 8x. Negative 4 times x is minus 4x, and negative 4 times negative 8 is positive 32. Now, this was a subtraction, so I'm going to have to change all of my signs, okay? So I'm just going to go ahead and change this to addition and change all of my signs. And there they go. Okay, so now I have a negative x squared plus 8x plus 4x minus 32. Okay, So now I have to group all my terms together. 2 plus a negative 1x is just 1x squared. Next, looking at my x's, I have an 8x and a 4x, so that's going to be positive 12x. And then I have 64 minus 32 is a 32. Okay, and all of that is divided by my common denominator of 8x plus 8 times x minus 8. Okay, so here I need to factor this top number. All right, and so in order to do that, I'm going to decide what two numbers multiply together to get 32 and add together to get 12. Well, I know that is 8 and 4. 8 times 4 is 32, and 8 plus 4 is 12. So I'm going to rewrite this to say x plus 8 times x plus 4 all over my common denominator of x plus 8 times x minus 8. All right, so here my x is crossed out. So my answer to the subtraction is x plus 4 over x minus 8. Now I'm not done yet because I have to identify any x values for which the expression is undefined. So in order to do that, I want to take each of these two pieces and check those. So x plus 8, when it equals 0, that would be x equals negative 8. And here we would have x equals positive 8. All right, so when x equals negative 8 or x equals positive 8, these make the expression undefined because these values make the factors x plus 8 and x minus 8 equal 0. And when they equal 0, we have an undefined expression. Okay. Some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. Examples of complex fractions are shown below. All right, so notice each fraction has a fraction within the fraction. So here we actually have two fractions. This is nothing new. You've done it with regular numbers, so now we're just going to be doing it with a little bit more interesting expressions here. So I just want you to remember that this bar in a fraction represents division. So when we see this bar, we really are just meaning division or to divide. So this would be x plus 2 divided by 3x. All right, therefore you can rewrite a complex fraction as a division problem and then simplify. You can also simplify complex fractions by using the least common denominator of the fractions in the numerator and the denominator. Let's do a few problems like that. Okay, so let's look at an example. So what we need to see here is we have this bar, and so that tells us we have a division sign. So actually what this means is just divide by x minus 3 over x plus 5. Now, if you will recall from our earlier discussions, we remember when we divide, we have to keep the first one, change the sign, and flip or do the reciprocal. So our new problem actually, so that we can solve it, is going to be x plus 2 divided by x minus 1 times x plus 5 over x minus 3. So in the end, we have x plus 2 times x plus 5 over x minus 1 times x minus 3. All right, and actually, since our question said all expressions are defined, that means we're not going to have any answers that would make it equal 0, so we get to assume that. And this is really all you need to write for your answer. You don't have to do anything more than this because this is in its simplest form, and it's easy to see whether there's anything else we can cancel out, which there's not. All right, in this example, again, we're asked to simplify, and we get to assume that all expressions are defined. So we're going to do this one a little bit different. This time, we're going to multiply the numerator and denominator of the complex fraction by the least common denominator of the fractions in the numerator and the denominator. So let's take a look at them. I have an x, and a 2. So that tells me my least common denominator is going to actually be 2x. So I'm going to multiply everything by 2x. All right, and when I multiply by 2x, some things cancel out. My x's cancel out, my 2's cancel out, and again, my x's cancel out. So that has gotten rid of all of my denominators. So now I can just multiply what I have left. I have a 6 plus x squared on the top, and I have an x minus 1 times 2 on the bottom. And actually, that is as far as there's nothing else we could factor out, nothing else we can do with that. And so that is actually our final answer. Okay, so now it's time for you to try a few on your own. Turn your video off and give it a try and see how you do. All right, so the first thing we want to do is remember that when I see a complex fraction, I really just have to remember that this just means divide. So I'm going to rewrite my problem, and I'm just going to set this up here, x minus 1. Now, again, in division, I want to keep, change, flip. All right, so I'm going to keep x plus 1 divided by x squared minus 1. I'm going to change it to multiplication and then find the reciprocal, x minus 1 over x. All right. Now, I'm almost there. I see that this piece right here is the difference of two perfect squares. So this one's actually going to be x plus 1 and x minus 1. All right, so let's go ahead and multiply everything out. So on the top, I have x plus 1 and an x minus 1 when I multiply these two together. And on the bottom, I have an x times x plus 1, x minus 1. So my x minus 1's cross out, my x plus 1's cross out. In the end, I have 1 over x. All right, and it says that assume that all expressions are defined. So my final answer is just 1 over x. Not too difficult. All right, again, try this one on your own. Turn the video off and then give it a try. All right, once again, I see that this is a division problem, and so I'm going to just go ahead and rewrite it as a division problem that I can recognize. 6 over 3x minus 3. I'm going to keep, change, flip. So I'm going to have 20 over x minus 1 times 3x minus 3 over 6. All right. Now all I have to do is just multiply through. One thing that I can see really easily is that I can factor this piece. So that is going to be 3 times x minus 1. And all of that is times 20. And all of that is over x minus 1 times 6. So my x minus 1's cancel out. 20 times 3 equals 60 divided by 6 equals 10. So your final answer is simply 10. All right. So a next one for you to try on your own. This time I'd like you to try to multiply the numerator and denominator of the complex fraction by the least common denominator of the fractions in the numerator and the denominator. So go ahead and see if you can do this one on your own. Okay, I hope that the first thing you found out was that the least common denominator is going to be 2x times x minus 2, because that's what is in common by both of them. So what I'm going to do is go ahead and multiply each part of these fractions by the common denominator, which is 2x times x minus 2. 2x times x minus 2. And 2x times x minus 2. Okay, so in the first fraction, 1x cancels out, and that leaves me with 2 times x minus 2 times 1. So I'll just keep that like that. In the next one, my 2x's cancel out, so that leaves me with just x minus 2. And then on the bottom, my x minus 2's cancel out, so now I'm going to distribute, or I'll just go ahead and keep it out for right now, 2x times x plus 4. Now I can't cancel anything out right now because I have this addition sign in here. You can only cancel when you have multiplication. So let's go ahead and get everything put simplify it and gather up our like terms and see if there's anything we can do in the end. So if I distribute this, I get 2x minus 4 plus x minus 2. So 2x plus 1x equals 3x minus 6 over, and I'll go ahead and actually I'll just leave this one the way it is, 2x times x plus 4. All right, and I can factor out at 3 out of here. That leaves me with x minus 2. So my final answer is going to be 3 times x minus 2 over 2x times x plus 4. And that is your final answer. And that is the end of our lesson. I hope you have a great day, and I will see you in class. Bye.